Hi, welcome again. We have a problem now to solve using transformation of graphs. Of course, this problem requires us to draw two different graphs on the same diagram. How are we going to go about this? You need to make sure that you know how each and every function will be written in terms of let's say maybe the first function f of x, it has to be something which is written. Okay, the second function must also be written in the same way. For the first type of a function, we said if it has a negative here, meaning that there will be what we call translation over the x-axis. Same even here, if it has a negative outside, it will have. If this same first function has got a negative on the part of x, the graph will be reflected. If this one is having a negative here, the graph can't be reflected. Why? Any number under modulus is always positive. So even if you have a negative x there, the graph won't be affected at all. But what do? We need to check, do these same functions have both the part of k and the part of x? If you check here, you notice that, of course, this, if you write it in a proper way, it will be f of x is equal to the square root of negative 2x plus 1. That has to be the best way of writing that same problem. If you come to the other one, this one is this one is already in a good way. So if you check properly, this is having a negative on the part of x, meaning that we expect to have a reflection for that same graph. Then it is already written in a form of x plus or minus a. So this part is the one which is going to help us calculate the value of x. So we don't have a constant, meaning that we won't have the movement in y-axis, but we have to get the movement in x-axis. So before we start sketching, first of all, we said to get the movement in x-axis, equate this to 0, it will be negative 2x plus 1 equal to 0, meaning that negative 2x is equal to negative 1, and x in this case is going to be equal to what? 1 over 2. So the graph that we are going to get as as the final graph of the steps I gave you, we'll need to move this number of steps in the x-axis. So which graph are we going to start with in this case? Of course, we have to start by coming up with a general graph. How do you come up with the general graph itself? The general graph, based on that same type of a function, it has to be in dotted lines. You draw it in dotted lines. So this function is square root of x. Due to the presence of a negative here, oh, by the way, since we have a 2, let's just try to write it direct. You put a 2 somewhere there. Due to the presence of that number, that sign which is here negative, it will cause this same function have a reflected graph which is going to face in the opposite direction, and this is going to be negative x. So it's this same reflected graph which is going to move in x-axis. Where is it going to move? From here, it has to go to the right hand side. Why? Because the value of x is positive, and all what you need to do is your graph will move in x-axis and it will come at this given position. So it has to face in the same direction, which is to the left hand side. When you happen to move in x-axis 1 over 2 units, you have to add positive 1 to that same last function. So your graph is going to face in this direction, and this is the same graph which is going to be negative 2x plus 1. This is the end of the same drawing of the first graph. Let's try to go to the second graph. The second graph, of course, has to be in this way. Since it's it has to be an absolute function which is here. Of course, first of all, you need to start by equating what is under modulus to 0. You say 2x plus 1 equal to 0. Then you have 2x equal to negative 1 over 2 over 2. That x value has to be negative 1 over 2. From there, you need to now come up with a sketch. So since this is an absolute function, we expect each general graph to be dotted that will be in that manner. I'll come up with 2x somewhere here. So since we have this as the value of x, we don't have the value of k, which is outside the modulus. If we had a value of k here, maybe let's say plus somewhere there, would have moved our graph even in y axis. So since it is not there, we expect this same function, or rather a graph, to move from here to the left hand side, because the value of x here that we have is -1/2. So our entire graph will move its point from here, it will come to -1/2, meaning that it will be pointing, just point in this direction. We don't really care where it will cut in the y-axis here, because they won't ask you something like that. So this is what we call 2x plus 1. For the domain and the range, you look at where these same graphs are starting from and where they are ending. Here in y-axis, that's where we have a range. So a range in this case will be, of course, we are starting from 0 going to the part of the positive side of y, meaning that your range has to be y has to be greater than or equal to 0. And domain, all the values of x will be member of a real number except this number which is here. X is the member of all your values where x is not equal to -1/2. That's the range and the domain for that one. For this one, we are starting from +1/2 going to the left hand side, meaning that we expect our domain will just be the same as x is less than equal to 1/2, less than or equal to 1/2. That will be a domain. Range, we are starting from the part of 0 in the y-axis going upwards, so just say y is greater than or equal to 0. Would you try to combine this function or that graph and this graph on a same diagram? You combine them, it will give you something like -1/2, and then the other one will start from here, which is going to be 1/2. This is the same graph these people wanted. Thank you very much. I'll drop some more questions down here for your own practice. The same questions I'm going to drop are those questions whereby you have a value of k. Before we come to that, I think if we go back, we need to know how to get the value of this part. How can you get the value of that part? The best is just square on both sides by removing the modulus. So you have square root of 1 minus 2x greater than 2x squared. Sorry, 2x plus 1. I'll square here. I'll also square on that part. And this is going to give us something like 1 minus 2x greater than 4x plus 4x plus 1. Try to do your calculations based on that until you get the values. Of course, if you try to push, that will be 1. Of course, let me try to do this 0 has to be, or we start with these. If you take them to the other side, it will be -4x squared minus 6x 0. So this is going to be 2x open -2x minus 3 0. There you have 0 comma -3/2. These are the values that these people wanted from this same part. Thank you very much for watching. Try to subscribe, share, and also leave a comment if it is making sense. The questions dropped here are supposed to be solved by you, and you'll be able to practice more. Thank you.